Hello everyone, my name is Patil Ashwin Kumar and I am from RBNB college. In the previous videos, as we were discussing about the aldehyde ketones and carboxylic acid, that is the compounds containing carbonyl group. Okay, in that we have seen the different types of classification, nomenclature and their preparation methods also. Now here in this video we are going to see what are the important chemical properties or what are the important chemical reactions that carbonyl group, specifically we are going to see the aldehydes and ketones, that aldehydes and ketones, which type of reaction this shows. Okay, firstly we have to note that the carbonyl group, that is a C double bond O. Firstly, we have to understand what is the polarity in the carbonyl group. Okay, when we see that oxygen is having lone pair of electrons, and as there is a large force of attraction as compared to the unsaturated carbon-carbon double bond, here when these bond breaks of carbonyl group, when these bond breaks of the carbonyl group, here the lone pair of electron is additional shifted towards the oxygen and we get the structure like this, where there is a partial positive charge on carbon and partial negative charge on oxygen. Means what? This carbonyl carbon act as electrophilic center, and this is act as a nucleophilic center. Meanwhile, we can understand, if we are going to see the chemical reactions, means addition of different types of reagents with these carbonyl group, means the negative part, whatever the negative part in the reagent is, it will automatically goes towards the electrophilic carbon. That is the electrophilic carbon towards the carbon. Let's see the first reaction, or the first reaction we have to see, that reaction with the or addition of hydrogen cyanide. Addition of hydrogen cyanide, HCN. All we can understand that the carbonyl group or the double bonded compound generally show the addition reactions. Instead of substitution, they show addition reaction. Here the HCN, it is a weak base and which on reaction with the carbonyl group gives cyanohydrins. Here look at the general reaction, we can see here R dash for aldehydes you can keep as hydrogen, and for ketone as it is the two different alkyl group. When hydrogen cyanide is added to these ketones or aldehyde, there is a formation of cyanohydrin. Cyanohydrin are compounds which contains hydroxyl group as well as a cyanide group at a time. These are the cyanohydrins. Here just we have to keep in mind that the HCN group, whenever there is a reaction between the hydrogen cyanide and unsaturated compound, that the HCN, it is a hydrogen cyanide. It act as weak base. Weak acid. It act as a weak acid. Mean you can take an example, any kind of example you can see. That the first example we can see CH3 C double bond OH. This is acetaldehyde. When it is added with hydrogen cyanide, it gives acetaldehyde cyanohydrin. Likewise CH3 CH this OH and this Cn. Simple. Then again, these are the same kind of reaction. If you take there is a acetone, the further product will be also the derivative of a cyanohydrate. Then there are different type of reaction we are going to see. The next one reaction is the reaction with the sodium bisulfite. Sodium bisulfite. When this sodium bisulfite also, there is a reaction between the carbonyl group. Just keep in mind, due to the polarity, that the carbonyl carbon act as an electrophilic center where the negative part of the reagent attacks, or where the negative part of reagent comes. Okay. Then the next second example we are going to see is addition of or reaction with the sodium bisulfide. Addition of sodium bisulfide. Second one, that the addition of sodium bisulfide. What is the formula for sodium bisulfide? We know NaHSO4. NaHSO4. It may be aldehyde or ketone. For aldehyde we have to take that. For this R we can take hydrogen. When aldehydes or ketone undergoes addition with sodium bisulfide, there is a formation of sodium bisulfite derivatives. Sodium bisulfite derivatives. Reaction takes place as like this. And here SO3Na. Okay, these are the sodium bisulfite derivatives. If you take the aldehyde, it will be the aldehyde sodium bisulfite, or if you take ketones, it will be the ketone aldehyde bisulfite. Okay. Then the next example, or many very crucial reaction of the aldehyde and ketones, is the addition of alcohol group. Addition of alcohol group, as there is a formation of hemiacetal or hemiketal group. What is the hemiacetal or hemiketal group? Reaction between the carbonyl carbon and hydroxyl group of alcohol results into the unstable intermediate product, that is a hemiacetal. When it again undergoes addition with the next alcoholic group, there is a formation of acetal or ketal group. In glucose, you have studied that the glucose show the two types of ring structure, that is alpha D glucose and beta D glucose. These ring structures of glucose, they show the hemiacetal structure. They show hemiacetal structure. What are these hemiacetal structure? Nothing but, as we know, in the glucose there is a formyl group, as a formyl group present, which is acting as a functional group, and that formyl group reacts with the one of the hydroxyl group present in the glucose molecule to form the hemiacetal group. Let's see how these aldehydes or ketone undergoes addition with alcohols. Undergoes addition with alcohols. Third one, addition of alcohols. Addition of alcohols. We have to keep in mind that when aldehydes, they undergo addition with the monohydroxyl or monoalcohols, monoderivatives of alcohols, not the diols or triols, in presence of dry HCl or acid catalyzed. This reaction is a acid catalyzed reaction. It undergoes to form alkoxy alcohol. Alkoxy group means one of the oxygen of that may be of carbon, that may be of carbonyl group, or that may be of a hydroxyl group, it will go for the alkoxy group, that is oxy group, and another remains as a alcohol. Okay, let's see. Here, this intermediate hemiacetal group means in case of aldehyde there is a formation of hemiacetal. In case of that ketones there is a formation of hemiketals group, which on further reaction with again same kind of monoalcohols, it will give acetal or ketal. Let's see. That is the R. This one is aldehyde. This one is aldehyde. When it reacts with monohydroxy alcohol in presence of, just we have to keep dilute HCl, and that it is acid catalyzed, that's why the dry HCl we are using, and these reactions are reversible. Meanwhile, by using the same solvent we can retain our aldehyde or whatever the alcohol it is. Okay, look at the structure formed due to the hemiacetal structure, that is R, C, this is a hemiacetal. One of the alcoholic group, that R group goes to the oxygen to form the alkoxy group. These are nothing but the alkoxy alcohol, we can say. These are the alkoxy alcohols. Here alkoxy, this group is a alkoxy group, and this one the alcohol, as we can say. Okay, but this is a unstable hemiacetal. These are unstable. That is why when these unstable hemiacetal again reacts with the same alcohols, then it will give the ketal, and structure will be like this. Again reacts with alcoholic group. There is a formation of ketal, just we have to note that the dilute HCl, it can act as a solvent medium, while a dry HCl, it acts as an acid catalyst. There is a formation of acetal group. This is the acetal, and it is a more stable compound. In case of ketone, they show the same reaction. But the intermediate product formed during the reaction of alcohols or addition of alcohols with the ketones, that is the hemiketal group. And these hemiketal on reaction with the same or one monoalcohol, it will give the ketal. Just there is one exceptional case for the ketones. What? That when the ketones, they reacts with 1,2 or 1,3 diols. 1,2 or 1,3 diols. Here we are using this monohydroxyl group. For the formation of hemiacetal or hemiketal and acetal group. But in case of ketones, they reacts with 1,2 diol or 1,3 diol to give, in presence of same acid catalyzed reaction, to give the cyclic ketal groups. And this is also a reversible reaction. This is also a reversible reaction. This reaction carried in presence of dry ether. In presence of dry ether. Look at the reaction of ketone for the preparation of cyclic ketal. Cyclic ketal. When they reacts with one two diol, it is a ethyl diol or ethane 1,2 diol. What we said, that ketones, when they react with 1,2 diol or that may be 1,3 diol, if it reacts with the 1,2 diol, there is a formation of cyclic compound containing 5 members. This will be the first, second, third, fourth and fifth. What is the structure? This will be the structure of cyclic ketal. Instead of this ethane 1,2 diol, if we use 1,3 propane 1,3 diol, likewise same reaction, the resulting cyclic ketal would be the 6-membered ring. It is a 5-membered ring. It is the first, second, third, fourth and fifth. In this case, that will be the 6-membered. Likewise, this will be the cyclic ketal. Acetals and ketals, when they are hydrolyzed with any mineral acids. Any mineral acids means mineral acids on hydrolysis, these acetals, which one? That we have seen that the compounds these are the acetals or these are the ketals. These acetals or ketones, when they undergoes hydrolysis with any mineral acid, there is again there is a reversible reaction and we get the corresponding starting material aldehyde or ketone from which we have derived these acetals and ketones. Again, next one, the reaction with the Grignard's reagent. The reaction with the Grignard's reagent. When aldehydes reacts with the Grignard's reagent, it is one of the method for the preparation of alcohols. One of the method for the preparation of alcohols. There is a formation of intermediate magnesium complex compound which on further hydrolysis means aldehydes or ketones, when they react with the Grignard's reagent, there is a formation of intermediate complex or magnesium complex compound which on further hydrolysis gives corresponding alcohol. How this reaction takes place? Have a note. The fourth one reaction. Addition of Grignard's reagent. That the corresponding aldehydes or ketone, when they react with Grignard's reagent, that is a RMgX, RMgX. As we know, reaction with the Grignard's reagent generally carried in presence of dry ether. Generally carried in presence of dry ether, there is a formation of complex. This intermediate, the magnesium complex, when undergoes hydrolysis, further it undergoes hydrolysis, there is a formation of alcohols. There is a formation of alcohols. In case we are taking hydrogen, it will be the secondary alcohol. In case we are taking the ketones, it will be the tertiary alcohol. Means with the addition of Grignard's reagent, we can prepare secondary or tertiary alcohols with the help of addition of Grignard's reagents to the carbonyl aldehydes or ketones. Carbonyl aldehydes or ketones. Okay.